Okay, so we've come to a point in the semester where we're going to have to focus on another math concept. Yeah, I know it's more math, more equations, more calculator stuff, but we tried to break it up on you at least. A part of it in the first half of the semester, and now a new part in the second half of the semester. And the issue here is going to be the word error. All of us have error. We've already talked about this before, right? We said that actually nobody is perfect in a laboratory, no matter what you do. And there's certain ways that we can kind of get around some of the error. There's a couple of ways that we can fix and minimize the error that we have to report. And we talked about this whole concept of average and standard deviation and 95% confidence interval, or just the confidence interval in general. But 95% is typically what we use. So there's other pieces to the puzzle, and there's other things that we can do to help process the error that's associated in a laboratory. We know that you're going to go in, we know that you're going to perform a task, and we know that there's error built into the system. So basically, what's going to happen here is no matter what you do, there's always going to be error associated with your measurements. No matter how perfect, even if you were perfect, there's going to be error associated with your measurements. Bottom line. All right, so let me kind of give you an example. Let's say that we take a weighboat and we take the mass of the weighboat in the laboratory. So I go to the scale and I tear it out and I put the weighboat on the scale and I get 1.3255 grams. And then I write down that number, and that's the number that I report. Well, let's say that someone else goes into the lab and takes the same weighboat, the same identical one, and weighs it on the same identical balance. They might report back 1.3258. And then you scratch your head, and they scratched their head, and they said, this is the same weighboat, and we use the same balance to weigh the same weighboat. So you take the weighboat back, and you do another measurement of the same identical weighboat, and you get 1.3251. And then the other person scratches their head and they say, well, this doesn't make any sense. We've done this 3 times now. I'm going to take the weighboat back and I'm going to reweigh it. And they get 1.3253. All 4 measurements are completely different. So the question here is, which one of these is the correct weight of the weighboat? Which one of these should we actually use in a laboratory? That's a big question, right? And especially in a quality control environment, because the issue here is that sometimes we have thresholds that we have to meet. And if those thresholds are or our values are slightly below the threshold or slightly above the threshold, we have to say that that substance fails. But if I could incorporate this type of error, this concept that no measurement is perfect and that no person is perfect, then there's a possibility that I could get things to pass based on the concept of error alone. We know that when we report a value, that value is not set in stone. So how would we actually process this? How would we attempt to fix this mathematically, knowing that it's the same weighboat on the same balance that's weighed 4 separate times? How do I know what the true weight of the weighboat actually is? All right, well, that's the process of this portion of the course. we're going to go through and we're going to talk about how to process this information and how to mathematically prove it. So the answer here is it's not that easy, all right? So you might say, well, we can average these, can't we? And we can just report an average. Or we can do a standard deviation, can't we? We can do that as well. And the answer is yeah. So what I can do here is that I can take the average of these four digits, 1.3255, 1.3258, 1.3251, and 1.3253. I can add them all up, divide by the number that I have, and allow Excel to do this for me. So if I do that, and I plug this into Excel or I do the calculation myself, my average here is 1.3254 grams. Well, that could be a better number to report, right? But this is nothing new. Like, why am I talking about this if we're just going to be doing averages for all of these calculations? Well, it doesn't stop here. There's actually other things that we're going to have to do with it. Standard deviation can be the same. Standard deviation is basically how close my numbers are to each other. And if I do the standard deviation for these four numbers in Excel, remember equals STDEV, and allow the calculation to perform in Excel, I get 0.003 or 0003, all right? So I can take these two numbers and I can report what we would call an analytical number. All right. Now, this is something that we really haven't actually done or talked about at this point in the semester. And an analytical number is basically the average 1.3254 plus or minus the standard deviation that's associated with those calculations. So 1.3254 minus 0.0003 is 1.3251, and then that number could go 1.3254 plus 0.0003, and that would go to 1.3257. Well, this is very similar to a confidence interval, but it's not really doing a confidence interval, right? Confidence intervals are really kind of taking into consideration the entire population of data. This average and standard deviation is just basically based on the actual number of measurements that I'm doing in the lab. So I'm going to say the true mass of the weighboat probably lies within this range, 1.3251, 1.3257. But I've got to do repeat measurements, right? I've got to do them over and over and over in order to obtain this data. Well, this analytical number, this would be the analytical number. This standard deviation represents the error that's associated with that analytical number. All right, so here's the issue. What does probably mean? Because we said that the answer probably lies in that window. And then what if we have a number that we've obtained in the laboratory and we do this with it? And what if this number has to be involved in some type of calculation? How do I handle that? Well, that's the actual heart of what you're getting ready to watch in this lecture series, recorded by me and myself, right? We're going to talk about how to handle analytical numbers. We're going to talk about how to do calculations with the analytical numbers. And we're going to talk about this word probably, right? It's not confidence interval here. This is basically your true foundation of statistics that we're getting ready to talk about. So in the next video, we're going to pick up from here and we're going to go on and we're going to talk about some of these calculations and maybe how to prepare myself for the world of statistical error. Buckle seatbelts, get the popcorn, get the no-dos. That way you'll pay attention. And I'll see you back in the next video.